Hi, I am R. Venkatesh, Assistant Professor in Electronics and Communication Engineering Department at Rohini College of Engineering and Technology, Anjigrapam, Palkulam, Kanyakumari district. In this slide, we are going to see an optical receiver configuration which is used in optical communication system. After the completion of this slide, student will be able to explain the basic concept of optical receiver configuration, and he can explain the probability of errors and inter-symbol interferences and quantum limit. Introduction: Receiver configuration. So in the receiver configuration, the basic receiver circuit is class subcategorized into three basic stages of receivers are photodetector and bias resistor unit, amplifier unit, and an equalizer unit. The photodetector and bias resistors are the input at the first part of an receiver configuration. So it receives the light signals which comes from the optical fiber cables and detects the light signals and convert it into electrical signal. Next, an amplifier unit. An amplifier unit is otherwise referred as the pre-amplifier unit. Here, the receiver amplifiers are the front-end pre-amplifier section. The sensitivity and bandwidth of a receivers are denominated by the noise sources at the pre-amplifier stages. The main goal are to maximize the receiver sensitivity while maintaining a suitable bandwidth of signals. Next, the equalizer unit. In the equalizer unit is a linear frequency shaping filter which is used to compensate the effect of signals distorted and inter-symbol interferences which is arised in the optical channel. It accepts the combined frequency response of the transmitter, fiber and the receiver and the transformer. It is to be signal response that is suitable for a following signal processing unit. The last unit is the signal processing unit. So here in the receiver, three basic stages of receivers is classified. One is photodetector and the amplifier and the equalizer. The photodetector can be either an avalanche photodiode with a mean gain of M or a pin photodiode with M is equal to 1. The photodiode has a quantum efficiency and a capacitor CD. The detector bias resistance has a resistance RB with which generated a thermal noise current IB of T. Next, the pre-amplifier unit. The amplifier input impedance is the parallel combination of a resistance RB and a shunt capacitance CA. Here, the voltage appearing across the impedance causes current to flow in the amplifier output level. When the amplifying function is represented by a voltage controlled current source which is characterized by a transconductance Gm. There are two amplifiers and their noise sources are represented. One is the thermal noise due to the resistors Ra and the noise voltage source Ea of T, which is represents the thermal noise of an amplifier channel. The noise source are assumed to be Gaussian and it is static and have a flat spectrum and have hence it is referred as the white noise. The equalizer is a linear frequency shaping filter which is used to compensate the effect of signal distortions and inter-symbol interferences. It accepts the combined frequency response of the transmitter, fiber and the receiver and the transforms it into a signal response that is suitable for following signal processing method. So the binary digital pulse train incident on the photodetector can be described by P of t is equal to summation n is equal to minus infinity to plus infinity Bn into Hp of t minus n capital TB, where P of t is equal to received signal power, Bn is equal to amplified of the nth message bit. Tb is the bit period and Hp of t is equal to received pulse shape which is positive for all time t. For a binary data, the parameter Bn can take two values B on and B off corresponding to binary levels of 1 and 0 respectively. If Hp of t is the non-negative photodiode input pulse that is to be normalized to having a unit area, then the mean output current from the photodiode at the time t due to pulse drain is given as R naught m summation n is equal to minus infinity to plus infinity Bn Hp t minus n Tb, where the quantum efficiency and responsivity of the detector is given by the current is then amplified and filtered to produce the mean voltage at the output of the equalizer. So in the receiver configuration, we are to find the bit error rate and quantum limit of a particular signal. So bit error rate. The bit error rate is defined by the ratio between number of errors Ne occurring over a certain time interval t to the number of error n of t during this particular interval, where bit error rate is equal to Ne divided by Bt. Quantum limit. So in an ideal photodetector which has an unity quantum efficiency and which produced no dark current, then that is no electron hole pairs are generated in the absence of an optical pulse. Then the minimum received power for a specific bit error rate is known as quantum limit. The main function of the optical receiver in the receiver configuration is the receiver must be first detect the weak signal and distorted signals and to make distortions for their channel process. Thank you.